is an AIPMT question in thermal properties of solids, particularly in calorimetry. The problem is like this. 10 grams of ice cubes at 0 degrees centigrade are released into a tumbler. So what he is saying is, there is ice whose mass is 10 grams. They are all released into a tumbler like this, whose water equivalent is, there is certain water which is not directly given for you, at a temperature 40 degrees centigrade. Ice is at 0 degrees centigrade. Assuming that negligible heat is taken from the surroundings, the temperature of the water in the tumbler becomes approximately how much? Here, one thing is very clear to all of you, that water is the hot body, ice is the cold body. According to principle of method of mixers, according to principle of calorimetry, when there is no loss of heat, that was mentioned in the problem also, heat lost by the hot body, here in this case water, and the tumbler is heat gained by the cold body, that is ice here. So the cold body, while gaining the heat, that is ice, do two things. What is that ice will do? At 0 degrees centigrade, when you give heat, it converts into water. For that, it needs some heat energy. Basing on the definition of latent heat, you can call that as ml. Mass of the ice is given to you as 10 grams. Latent heat of ice is 80. So for that, it need 800 calories of the heat. Now this is no more ice, that is in the format of water, whose temperature will rise from 0 degrees centigrade to a new temperature x degrees centigrade. We have to calculate what is the temperature is. That is the heat gained by the cold body. Who will give that heat? This hot water gives that heat, right? So heat given by water as well as the tumbler together is mass of that, specific heat of that, and a delta T. Mass into specific heat, delta T is, it falls from 40 to x, whereas ice rises from 0 to x, where x is the intermediate temperature and we need to calculate that. Instead of mass and specific heat, which is called as thermal capacity, a water equivalent is given for you. Water equivalent's numerical value is similar to that of the thermal capacity, though the unit is of grams. So the m into s, thermal capacity, is given to you as 55 into 40 minus x. So I can write now heat lost by the hot body equal to heat gained by the cold body according to principle of method of mixers. Heat lost by the hot body is 55 into 40 minus x. Heat gained by the cold body is mass of the ice into latent heat of the ice, mass of the water that is converted from the ice, specific heat of the ice is 1, water is 1, delta T is from 0 to x, so x. So let us simplify this. 55 into 40 minus 55 into x is 10 into 80, 800, 10 into 1 into x is 10x. So 55 into 40 minus 800 equal to 10x plus 55 into x. So that's altogether 65x. I can take a 40 common here, 55. If I have taken 40 out of that, 40 into 20 is 800, right? Therefore 20 is there. So 40 into 35 by 65 is the value of the x. That's the resultant temperature, right? So we can further Write as 5 sevens are 35. 5 ones is 5, 15 is that 13, right? So value of the x is 40 into 7 by 13. If it is 14, 7 by 14 is half, the answer could have been 20. But it is 13, so it will be a little more than half. That is, I mean to say this 7 by 13 is going to be greater than 0.5. So your answer is going to be more than 20, little more than 20. So the best possible answer that is more than 20 is 22 degrees centigrade. I need not even do the calculation. We can get that answer. That's how we get this answer. So while we are solving this, we use the principle called principle of calorimetry, that heat lost by hot body equal to heat gained by the cold body. That's it. Thank you for watching.